Hello everyone, let's continue exercise 6.3. Fourth question, prove that the following functions do not have maxima or minima. First function is f of x is equal to e raised to x. As usual, we will find f dash of x first derivative, then set f dash of x is equal to 0 to find the critical points. Okay, let's check whether these functions have maxima or minima. Okay, so here first of all let's find f dash of x. F dash of x is equal to e raised to x itself. That is, derivative of e raised to x is nothing but e raised to x itself. So f dash of x is equal to e raised to x. Next step is f dash of x is equal to 0 for critical points, right? So e raised to x is equal to 0. F dash of x is equal to 0 implies e raised to x is equal to 0. See here, it is not possible. We know that the exponential function is always greater than 0. Okay, that is, e raised to x is always greater than 0. So e raised to x is equal to 0 is not possible. Is not possible. Therefore, the given function f of x has no maxima and minima. Okay, then second one is g of x is equal to log x, here x greater than 0. Okay, so here also let's find g dash of x, first derivative of g of x, that is derivative of log x with respect to x is 1 by x. Then next, g dash of x is equal to 0 implies 1 by x is equal to 0. See, when 1 by x is 0, when x greater than 0, when 1 by x is 0, see 1 by x, as x tends to infinity, 1 by x tends to 0, right? So here, which is not possible. See, if x is equal to infinity means as x tends to infinity, 1 by x tends to 0. So it is not defined. So here it is not possible. Therefore, g of x is also have no maxima and minima. Okay, g of x has no maxima and minima. Then third function is h of x is equal to x cube plus x square plus x plus 1. Okay, so here let's find h dash of x is nothing but 3x square plus 2x plus 1, right? So here we have got a quadratic equation, right? So let's find that is discriminant. Okay, discriminant of the quadratic function. We know that if the discriminant is greater than 0, then this quadratic equation has real roots. Okay, or if we get, that is, if discriminant is less than 0, then quadratic function has no real roots. It will be complex roots, right? So here let's check. Discriminant is nothing but b square minus 4ac. b is 2, that is 4 minus 2 into 3 into c is 1. Okay, sorry, c is 1. Okay, that is 4 minus 6, c minus 2, that is less than 0. Here we have got discriminant of this quadratic equation is less than 0. That means this quadratic equation has no real roots. That means the values of x, okay, the values of x is not real numbers. Therefore, here this h of x is also, this function has no maxima and minima. That's all. Find the absolute maximum value and the absolute minimum value of the following functions in the given intervals. First function, f of x is equal to x cube. X belongs to closed interval minus 2 to 2. Okay, so here we have to find absolute maximum and minimum values. Okay, so here let's check what is the least value of x and at most value of x. That means minimum value of x and that is maximum value of x. Okay, so here first of all let's find f of x, f dash of x, that is 3x square. Then let's find the value of x, that is critical point. F dash of x is equal to 0 implies 3x square is equal to 0, that implies x is equal to 0. Okay, so x is equal to 0 is the critical point. So here let's find what is the value of the function when x is equal to minus 2. Here minus x is equal to minus 2 is the least value of x, right? So here when x is equal to minus 2, f of minus 2 is equal to here minus 2 whole cube, that is minus 8. Okay, and when x is equal to 0, f of 0 is equal to 0. Okay, then the maximum value of x is nothing but 2. Okay, since it is a closed interval, minus 2 and 2 are included. Okay, so when x is equal to 2, f of 2, that is equal to 2 cube is 8. See here, what is the minimum value of the function? See, minimum value is nothing but, that is minimum of minus 8, 0, 8. So here minimum value is minus 8. Therefore, the absolute minimum of the function, minimum value of the function is nothing but minus 8. Okay. So here we can write absolute minimum value of the function is equal to minimum of minus 8, 0, 8. That is minus 8. So minus 8 is absolute minimum value. Then what is absolute maximum value? Here we have to find only absolute minimum value and maximum values. Okay. So absolute maximum is equal to maximum of minus 8, 0, 8. That is nothing but 8. 8 is the maximum. So minus 8 is the absolute minimum and 8 is the absolute maximum. The next function, f of x is equal to sin x plus cos x. X belongs to closed interval 0 to pi. Here also we have to find absolute maximum and absolute minimum value. Okay, f dash of x is equal to sin x, derivative of sin x is nothing but cos x. Derivative of cos x is minus sin x. So next, f dash of x is equal to 0, that implies cos x minus sin x is equal to 0, that implies cos x is equal to sin x. Okay. See, cos x is equal to sin x means, see, x is equal to pi by 4, right? X is equal to pi by 4. This implies x is equal to pi by 4. And this pi by 4 belongs to this interval. Okay, so x is equal to pi by 4. So here, what is the least value of x? Least value of x is 0 and at most value of x is pi. That is minimum value of x is 0 and minimum value of x is pi. So let's substitute. Find f of 0. Okay, here we have to find absolute maximum and absolute minimum. Okay, so find f of 0. What is f of 0? That is sin 0 plus cos 0. That is sin 0 is 0, cos 0 is 1. Okay, then next we will find this value. This pi by 4 is also belongs to interval, right? X belongs to 0 to pi. Okay, this interval. Pi by 4 belongs to this interval. Okay, so f of pi by 4, that is equal to sin pi by 4 plus cos pi by 4. Sin pi by 4 is 1 by root 2 plus cos pi by 4 is 1 by root 2, that is 2 by root 2, that is nothing but root 2. Okay, next we will find the most value, that is maximum value of x, that is pi. So f of pi is equal to sin pi plus cos pi, that is equal to sin pi plus cos pi. So here sin pi is 0 plus cos pi is minus 1. So the value is minus 1. So what is the minimum, absolute minimum value of this function? That is minimum of 1 root 2 minus 1. See here minus 1 is the minimum, right? Therefore absolute minimum value of the given function is minus 1. Okay? Therefore absolute minimum value of f of x is equal to minimum of, see what are the values we have got? 1 root 2 minus 1. 1 root 2 minus 1. So that is equal to minus 1. Minimum of 1 root 2 minus 1 is nothing but minus 1. Therefore, absolute minimum value of the given function is minus 1. So what is the absolute maximum? Absolute maximum value, that is equal to, here see, maximum of 1 root 2 minus 1, which is greater. Root 2 is greater, right? We know that root 1 is 1. Okay, so root 2 is always greater than 1. Okay, therefore root 2 is the maximum value among these values, right? So therefore absolute maximum value of the function is root 2. Okay, absolute minimum value of this function is minus 1 and the absolute maximum value of this function is root 2. The next given function is f of x is equal to 4x minus 1 by 2 x square. Here x belongs to closed interval minus 2 to 9 by 2. Here also we have to find the absolute minimum value and absolute maximum value. So first we will find the f dash of x. F dash of x is equal to derivative of 4x is 4 minus 1 by 2 into derivative of x square is 2x. 2 cancelled, so 4 minus x. Then set x, f dash of x is equal to 0 for critical point, that is 4 minus x is equal to 0, that implies x is equal to 4. Okay, so x is equal to 4. Now let's check, let's find the least value of x, that is minimum values of minimum value of x and maximum value of x. Minimum value of x is minus 2. So what is f of minus 2? F of minus 2 is 4 into, substitute x is equal to minus 2 in f of x. Okay, 4 into minus 2 minus 1 by 2 into minus 2 square is 4. Okay, that is equal to, here minus 8, 2 cancelled, so 2 minus 8 minus 2, that is minus 10. Okay, then what is next critical point, that is f of 4. Then we will find f of 4. What is f of 4? Substitute x is equal to 4. 4 into 4 minus 1 by 2 into 4 square, that is 16, that is equal to 16 minus, this term will be 8. That is 16 minus 8 is 8. Next we will find the maximum value of x, that is 9 by 2. So what is f of 9 by 2? Here substitute x is equal to 9 by 2. 4 into 9 by 2 minus 1 by 2 into 9 by 2 square, that is 81 divided by 4. Okay, square of 9 by 2 is 81 by 4. That is equal to, here 2 9s are 18 minus 81 divided by 8. Okay, that is equal to, okay, let's take LCM. So 8 is the LCM, so cross multiply, 18 into 8, 144 minus 81 divided by 8, that is equal to 63 divided by 8. Okay, so here what are the values we have got? Values of the function, that is minus 10, 8, 63 by 8. Okay, so here let's find what is the minimum value, absolute minimum value. Okay, absolute minimum value is equal to minimum of, what are the values? Minus 10, then 8, 63 divided by 8. So here absolutely, see, minus 10 is the least value, right? So here minimum of minus 10, 8, 63 by 8 is nothing but minus 10. Therefore absolute minimum is minus 10. That is, absolute minimum value of the given function is minus 10. And what is the absolute maximum? Absolute maximum, that is maximum of minus 10, 8, 63 divided by 8. See, here which is greater, 8 or 63 by 8? We know that 64 by 8 is nothing but 8. So this, it is 63, that is less than 64, right? So here it is 63 by 8 is always less than 8. Okay. Obviously this 63 by 8 is less than 8. Therefore 8 is the maximum. Okay. So 8 is the maximum value. So next function, f of x is equal to x minus 1 whole square plus 3, and here x belongs to closed interval minus 3 to 1. So here f dash of x is equal to 2 into x minus 1, derivative of 3 is 0. Then f dash of x is equal to 0 implies 2 into x minus 1 is equal to 0, that implies x is equal to 1. X minus 1 is equal to 0 implies x is equal to 1. So next we will find, see what is the minimum value of x, that is minus 3, right? F of minus 3. Find f of minus 3. Put x is equal to minus 3 in f of x. So minus 3 minus 1 whole square plus 3. That is minus 4 square is 16 plus 3, that is 19. Then our critical point, x is equal to 1, so f of 1. F of 1 is equal to, put x is equal to 1, so this term will be 0. So f of 1 is equal to 0 plus 3, that is 3. Then what is the maximum value? That is also 1. Okay, no need to find. So here among these values, which is minimum, that is 3, which is maximum 19, right? So here we can say absolute maximum value, therefore absolute, okay, minimum value is equal to minimum of 19 and 3, okay, 19, 3, that is equal to 3, okay. That is absolute minimum value of the function is 3 and absolute maximum value is maximum of 19 and 3, that is equal to 19. Therefore, here absolute maximum value of the given function is 19. Look at the next question. Find the maximum profit that a company can make if the profit function is given by p of x is equal to 41 plus 24x minus 18x square. So here it is the given function. Here we have to find maximum value of the function, that means maximum profit. Okay. So here let's apply second derivative test. You can apply first derivative test also. See here, let's apply second derivative test. If second derivative test fails, then let's go to first derivative test. Okay. So let's find p dash of x. That is derivative of 41 is 0. Derivative of 24x is 24 minus derivative of minus 18x square is 18 into 2x, that is 36x. Here 12 is common. Let's take 12 outside. So 12 into 2 minus 3x. Then set p dash of x is equal to 0. Okay, that implies 12 into 2 minus 3x is equal to 0. That implies, take 12 right side. So it will be 2 minus 3x is equal to 0. That implies x is equal to 2 by 3. Right? 2 minus 3x is equal to 0 implies x is equal to 2 by 3. So it is the critical point. Okay. So what is the next step? For second derivative test, we have to find second derivative, right? That is derivative of p dash of x with respect to x. So p double dash of x is equal to, it is our p dash of x, derivative of 24 is 0, derivative of minus 36x is minus 36, that is less than 0. So by the second derivative test, we say this function has maximum value at x is equal to 2 by 3. Okay, that is this function has maximum value when x is equal to 2 by 3. So what is the maximum value of the function? That is p of 2 by 3. Means when substitute x is equal to 2 by 3 in given function. Okay, that is by the second derivative test, function p of x has maximum value when x is equal to 2 by 3. So here maximum value of the function is nothing but maximum profit. Okay. Therefore maximum profit is equal to So how to find maximum value of the function? Substitute x is equal to 2 by 3 in given function, right? That is p of x. So p of 2 by 3. P of 2 by 3, that is equal to, substitute x is equal to 2 by 3. 41 plus 24 into 2 by 3 minus 18 into 2 by 3 square. That is equal to 41 plus 3 8s are 24. So 16 minus 4 by 9, right? So 9 2s are, so 2 into 4, 8. That is equal to 16 minus 8, 8. So 41 plus 8 is 49. So maximum profit, so rupees. Okay. So maximum profit is rupees 49. Find the maximum and minimum value of 3x raised to 4 minus 8x cube plus 12x square minus 48x plus 25 on the interval, closed interval 0 to 3. Here interval is given, that means x belongs to closed interval 0 to 3. So here let's find the minimum, that is least values of x and most values of x, that is maximum values of x, and in these values, and find the critical points. Okay, in these values what is the values of the function? Okay, so from this we will find maximum and minimum values of the function. So for that, first of all let's find f dash of x. Here it is our f of x, then f dash of x is 12x cube minus 24x square plus 24x minus 48. F dash of x is equal to 0 implies 12 is common, right? So take 12 outside. 12 into x cube minus 2x x square plus 2x minus 4, that is equal to 0. 12 into, here we have to find the factors, right? So for that, here let us consider these two terms. So take x square outside. So x square into x minus 2 plus, here take 2 outside, 2 into x minus 2, right? That is equal to 0. So that implies 12 into, here in both terms x minus 2 is common, let's take it out. So x minus 2 into x square plus 2, that is equal to 0. Okay, so here this implies 12 into, here x square plus 2 is equal to 0, that is x square is equal to, it is not possible. X square plus 2 is equal to 0 is not possible. Why? Because see, x square plus 2 is equal to 0 implies x square is equal to minus 2. Okay, that means x is equal to square root of minus 2. It will be a complex number, imaginary number. Okay, so here our real values, and it is given that x belongs to closed interval 0 to 3. Therefore here x square plus 2 is not equal to 0, but x minus 2 is equal to 0. That implies x minus 2 is equal to 0 implies x is equal to 2. So x is equal to 2 is the critical point. Okay, now let's find the values of the function. First of all, least value of x, that is here x belongs to closed interval 0 to 3. So what is f of 0? So f of 0 is, substitute x is equal to 0 in f of x, 3 into 0 raised to 4 minus 8 into 0 cube plus 12 into 0 square minus 48 into 0 plus 25. All these terms will be 0. So remaining 25. Okay. Then find f of critical value, that is f of 2. So f of 2 is equal to, substitute x is equal to 2, 3 into 2 raised to 4 minus 8 into 2 cube plus 12 into 2 square minus 48 into 2 plus 25. So this total will be minus 39. Okay. Then find, see, maximum value of x, that is f of 3. F of 3 is equal to, here also we have to substitute x is equal to 3 in f of x. So 3 into 3 raised to 4 minus 8 into 3 cube plus 12 into 3 square minus 48 into 3 plus 25. See, after the calculation we will get 16. Okay. So here we have got the values of the function 25 minus 39, 16. So maximum value of this function is nothing but, see, what is the maximum value among these values? 25 minus 13, 16. Maximum is 25 and minimum is minus 39. Okay. So maximum value is equal to 25 and minimum value is equal to minus 39. Okay. Next question, at what points in the interval closed interval 0 to pi, 2 pi, does the function sin 2x attain its maximum value? See, here given function is sin 2x and here x belongs to closed interval 0 to 2 pi. We have to find at which point, okay, at what point the given function is maximum. Okay, so here let's find, okay, let's write f of x is equal to sin 2x, then find f dash of x. F dash of x is equal to 2 cos 2x, right? Here x belongs to closed interval 0 to 2 pi. Okay, then let's find critical points. F dash of x is equal to 0 implies 2 cos 2x is equal to 0. That implies cos 2x is equal to 0. See, when the cos is 0, so what is the values of 2x? Here we know that cos of 2n plus 1 pi by 2 is 0, right? Cos 2n plus 1 pi by 2 is equal to 0, right? So here, that is when n is equal to 0, cos pi by 2, that is 0. When n is equal to 1, cos 3 pi by 2 is 0. Okay, cos 5 pi by 2 is 0. So here 2x is equal to, that is, first one is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, then 9 pi by 2. But this 9 pi by 2 does not belong to this interval. Okay, here it is given x belongs to 0 to 2 pi. Okay, therefore here this implies 2x is equal to pi by 2. Okay, because we have this cos of 2n plus 1 pi by 2 is equal to 0. Okay, at which angles, at which values cos is 0, that is 2n plus 1 pi by 2, cos of 2n plus 1 pi by 2 is 0. Here n is equal to 0, 1, 2, 3, etc. Okay, so here first one is when n is equal to 0, cos pi by 2 is 0, then cos 3 pi by 2 is 0, then cos 5 pi by 2 is 0, 7 pi by 2, then 9 pi by 2, but 9 pi by 2 does not belong to this interval. Okay, here till it is 8 pi by 2. We know that 2 pi is nothing but 8 pi by 4. Okay, so here because it is 2x, okay, so this implies x is equal to, here x belongs to closed interval 0 to 2 pi. So here we will get x is equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. See here if we write 9 pi by 4, 9 pi by 2, it will be 9 pi by 4. It does not belong to this interval, okay, because we know that till 2 pi is nothing but 8 pi by 4, right? So these are the values. These values belong to this interval, okay? And so next is find the values of the function, okay? So one by one let's find. First of all, f of 0. Here f of 0, that is equal to, because 0 is the least point, least value of x, that is f of 0 is equal to sine 2 into 0, sine 0 is 0. Okay, then let's find f of pi by 2. F of pi by 2, that is sine 2 into pi by 2, that is equal to sine pi is 0, right? So next, let's find f of 3 pi by, f of pi by 4, right? Okay, pi by 4. So it is pi by 2. Sin pi by 2 is 1. Okay. Then 3 pi by 4. Our x values are pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Okay. So next we will find f of 3 pi by 4, that is equal to sin 2 into 3 pi by 4, that is equal to, here 2 2s are, so sin 3 pi by 2. So what is sin 3 pi by 2? We know that sin pi by 2 is 1. Okay, sin 3 pi by 2 is, see, if you forget this value, then you have to apply this method. Sin 3 pi by 2 is sin pi plus pi by 2, right? Sin pi plus pi by 2. The pi plus, it will be lying in second quadrant. Sorry, pi plus in third quadrant, right? That is, here it is pi. So pi plus, sorry, it is pi by 2, pi 0. Okay. So pi plus means third quadrant. So it will be in third quadrant, and in third quadrant sign is minus, right? So sign is minus. Therefore, this value will be minus sin pi by 2. Okay. Sin pi plus pi by 2 is minus sin pi by 2. Sin pi by 2 is minus 1. So it is, sorry, sin pi by 2 is 1. So it will be minus 1. Okay. So sin 3 pi by 2 is minus 1. And next, f of 5 pi by 4. See, how to find sin 5 pi by 4? Sin 5 pi by 4 is 5 pi by 4 is equal to sin 2 pi plus pi by 4, right? So here we need to find sin 2x, right? Our function is sin 2x. So 2 into 5 pi by 4. So it will be sin 5 pi by 2. Okay. So we have to find sin pi by 5 pi by 2. Okay. So sin 5 pi by 2 is equal to sin of 2 pi plus pi by 2. That is, see, cross multiply 2 pi into 2, 4 pi, 4 plus pi, 5 pi. So here 2 pi plus, it is 2 pi. 2 pi plus means again first quadrant. Okay. So in first quadrant all are positive. Okay. Therefore sin 2 pi plus pi by 2 is nothing but sin pi by 2 itself, that is 1. Okay. Therefore sin 5 pi by 2 is 1. Okay. Again next, sin 7 f of 7 pi by 4. That is equal to sin 2 into 7 pi by 4, that is equal to sin 7 pi by 2. See, in this method, same method we can find. So here you will get minus 1. Sin 7 pi by 2 is equal to minus 1. Okay. So next, last value, that is maximum value of x, that is 2 pi. So what is f of 2 pi? F of 2 pi is equal to, substitute x is equal to 2 pi in f of x, sin 2 into 2 pi, that is sin 4 pi, that is equal to 0, because we know that sin n pi is equal to 0. Okay, these all things we have already studied in trigonometry functions. So here sin n pi, okay, sin n pi is 0, therefore sin 4 pi is equal to 0. So here what are the values of the functions we have got? 0, 1, minus 1, 1, minus 1, 0, right? So here we have to find at what points in the interval 0 to 2 pi does the function sin 2x attain its maximum value. See, what is the maximum value here? 1, right? So 1, that means sin, what are the values? F of pi by 4 is 1 and f of 5 pi by 4 is 1. Okay, therefore at these points, at x is equal to pi by 4 and at x is equal to 5 pi by 4, the given function attain its maximum value. Okay, so here at x is equal to pi by 4 and x is equal to 5 pi by 4, because 1 is the maximum value among these values, right? So here Therefore, f of pi by 4 is 1 and f of 5 pi by 4 is 1. Therefore, at these points, at x is equal to pi by 4 and at x is equal to 5 pi by 4, this function, that is this function sin 2x, attain its maximum value. Given function attain its maximum value. That's all. So what are the points? X is equal to pi by 4 and 5 pi by 4.